Alright, thanks for tuning in. Vince from Vince's Computer Repair here. So we have a job. It's partway through already. This control board here is from a newer Honda vehicle. Keep it simple. These are the two original factory chips that were on this board. Right now we're looking at a close-up view of the two basket IC or integrated circuit holders that I installed, and there's still some flux and whatnot there, but it's not conductive, so I can't really clean it. If I start using a Q-tip, it just makes a big mess of fibers, so it's good. But the point we're at here, and the reason that I should back up, the client came to me because it's got cold weather starting problems, and he did all his own research and discovered that you can buy aftermarket chips that are pre-programmed, and I have those, and what we're going to do is put them into these two baskets, and then if he ever wants to change to another set of chips, he doesn't need someone like me to remove the factory ones and put in, aftermarket. So that's the idea. In the first video I removed the two original, and I didn't record all of this because this was new and I just didn't get around to recording about. The stage we're at now is that I have them successfully installed. The idea is you want to get them in without burning them. So let's see, if I go over here, maybe I can give a better close-up. The light's not great of what it looks like. Bear with me here a second. And let's see. So that's them on the bottom here. Okay, they're about the size of a fingernail, a little bigger. Anyways, I haven't got proper lights set up, so again, this is a close-up view of them. Let's get them back into view here. So the important thing here is to make sure that every single pad, which is a trace, I'm going to go through total basics, but for those interested, you look at a circuit board, what do you see? A mass of components, right? And you're like, wow, it can be overwhelming. But the important thing to know is that the current, the electricity, is going to flow through paths to perform different functions and to get different components doing different things. So this is more about soldering than it is about how integrated circuits and circuit design works. What we're going to do is we're going to use our meter, and we have it in continuity mode, and we're going to put one probe on this lead, if you will, and this was a solder point. So I can see that it beeps when I have continuity. It means that basically I've got good connection from here through the pin and onto the main board itself. So that's a good thing. And when we check the next one, we don't want to have it beep because that would mean that there's solder in between, or there's a connection where there should not be. They're separated for a reason because they carry signals, electricity, timing, etc., etc. So on the second one, we have continuity as well. Third. What I like to do is first test to make sure I got continuity, and then check behind and in front to make sure I don't have any what are called bridges. I don't have a short circuit. I don't have a connection between two of them because, like I said, they need to be separate. So far so good. Sometimes you need to double check, but anyways, this is just an idea. So I could go through them all. You see people do this kind of stuff and speed up the video. If I get around to, I'll edit it properly. So far so good. I've already tested these prior because this job needs to get finished today, so I'm not going to bother doing all of them again, but just thought I'd give you an idea of what that last step looks like. And then for those interested, we pull out one of these aftermarket ignition control chips. If I can get it out of there. This is what it looks like. It's still in the package, but we'll take her out. Tell you, sometimes you gotta have patience with these little components, because it's like, if you rush stuff, they get broken. Like, there's little pins and it's so easy, but there's, I'm gonna put it on top. There's two of them, and hopefully my job is done and I did it right. Pretty sure I did. And these are just gonna push right in there. Okay, that's what they look like. So my connections are solid. This isn't going anywhere. There's a little bit of residue, but I can't clean that. Maybe with a brush I could. If that's a bit hack, then whatever, I'll improve. I mean, I could do this. I could use a toothbrush, one that's not all grody. The last thing you want to do is introduce contaminants so you get a poor connection, but essentially we'll use our isopropyl alcohol and we can get some of that out. So actually I might do that. I'm going to pause the video here for a second. Alright, so I'm back. I've got a better toothbrush, and this is my little squirting machine here. So that's filled with isopropyl, so get it wet and let's see what we can do here. Is it? Yeah, so you can see you can get in there. I thought it was like turning blue for a second. It's the bristles. So you want to clean it out, do a pro job the best a guy can. But if there's a little bit of flux residue, it's no big deal. It can sit in there. It's not going to do anything. Like I say, it's not conductive, so it flows all over the place. It'll be sticky, but it's inside of a car's dashboard, so there's no fire risk. Who cares? So that's about the best guy can do. And I think I'm happy with that. So that's it. Let's get rid of that. We can turn on our heat. There's the old heat nozzle here. I'm just going to help evaporate some of that, and you can see it just sucks her back up. And this is the primary tool used for extracting. The fun that I had was I had to find temperature that would flow my solder without melting these baskets, because if they deform, you have plastic all over the place. It's not going to roll too well. So once you start smoking, ease off. I'm just doing this to clean up that ISO. We're good. I used 341 degrees, which is a lot less than what guys use, but I could tell that it was starting to melt. You can see here there was a little bit of scoring and deformation. It was starting to melt, so I backed off. And some of my pins aren't perfectly aligned, but that's okay. As long as they're not touching, I tried to do my best there, but the problem I had was there's this big resistor over here. And the damn thing was just, the wire from it was just in the way of the corner of this one. So these pins are a little off. But like I say, as long as they're solid, they don't break, they don't move. That's what we do, we test them as well, and there's no wiggling. And there isn't. So that's pretty much it. I should be able to put these chips in, put it back in the housing, give it back to the client, get paid, and we'll see if it works for them. So there's no wiggling here. I'm pushing, right? I made this probe with a needle because I need to have real precision in here, right? You can see it's just like dinky. So these are the two chips. They're gonna go in. Hopefully they're gonna pop straight down and in. I might as well do it now. Alright, so I was checking something, but essentially that's it. So these aftermarket chips, they sit right in there like that. And they get pushed right in. should be it. Corner goes to the square. Alright, thanks for watching. Stay tuned for another one.